So basically, the difference between analog and digital is in the digital realm, like we've said and found out and explained, you have an on-off, true, false, high, low, however you want to think about it, 1, 0. In analog, and it kind of explains it here, there's a whole range of values. So with these chips, they turn an incoming value into a number from 0 to 1023. This is entirely because of the hardware itself. It has a limitation of how many discrete steps that it can break the signal up into, and that's how many steps it can break it up into, which relates directly to a voltage between 0 and 5. So if you're using the knob, which is like a potentiometer basically, so like a knob on your stereo at home or anything like that, anything you're physically turning on an amp or a guitar, anything like that, generally is going to be one of these. And effectively what it is just a big disc that has a 0 on one end and a 5 on the other end, and you're just turning a wiper across the whole thing. So you can go right from 0 all the way up to 1023, back down if you want. So if you still have your LEDs hooked up into 11 and 12, that's awesome. You can just plug in the rotation brick, which is, it looks like a tall black cylinder sticking out of a silver box. And it says rotation on it, this sucker. If you hook that up into A1, yes, if you hook it up into the A1 spot, then you're going to be able to play with analog inputs. And there's all kinds of different fun things you can do with that. This will show off one of them, and we'll get more and more into the analog stuff, because that's where the real power of embedded electronics comes from. Because a computer can measure all kinds of different digital stuff, but it's very, very difficult with the computer to do analog anything, really, unless it has specific hardware. So that's one of the key things that the Arduinos are really handy for. Even if you just think of it as a peripheral to your computer, you can use it to measure things in analog in the real world. So the temperature, or the light, the amount of light in the room, or all kinds of different things. How much someone has turned a dial, whatever. So yeah. And the lesson will probably get rid of, so the code actually gets rid of some of the stuff we've already been having to use. Okay. And it also introduces another kind of variable. So once you guys have this code in, then give me a heads up, and I will talk about how this variable works and how you use variables in general outside of just the booleans that are on, off, yes, no. Okay, so we've taken out some code here. We've changed what's going on down here. So this is a new variable. Before we were talking about booleans, they can be 1 or 0, high, low, true, false, whatever. Int is short for integer. So if you say an int, and then give it a name, we would call it del or something, because they're too lazy to write delay. And they just said 0, just because they wanted to give it an initial value. You don't have to give it an initial value as long as you're assigning something to it at some point. So you can either say equals 0 or just say int del semicolon, and it'll just be fine. And we've set up 2 pins as outputs. One thing that you should remember is that if you want to use a pin as an input, you do not have to tell the compiler that you want an input, because it defaults to using everything as input. So that's something that saves a little bit of code on your end, because it will automatically assign everything to an input and then only make things output if you tell it to. So if you want to use a sensor, you want to use rotation, whatever, you're fine. And then in here, we're just doing an analog read. And if you're doing an analog read, then it'll only read from the analog pins. So 1 is like A1, basically. And it'll read in the result, and it'll store it, just like we did when I was talking about the buzzer on, buzzer off, the button press thing. It actually stores the value that it reads into this variable, right, into this integer. And the integer can hold numbers, uninteger, defined like this, where it's int name something, can hold numbers from negative 65,000 to positive 65,000. So you're in no danger of going into any kind of weird memory space or stuff, which is one of the big issues that most people have with embedded space, is they've just kind of done all that in the background and you don't have to worry about it. So then all it's doing is it's turning on one LED and off the other one, right? You guys have done already. And then it's delaying by however long it read in on the analog read. So some number of milliseconds, which is from 0 to 1023, like I was saying earlier for the analog reading. And then it'll turn the other one on and then wait that same amount again. So effectively what it's going to do is just switch back and forth between turning the LEDs on and off, but the dial will adjust how quickly it does that. Because it'll have one on and then wait, and then one off and wait, and then read it, and one on and wait, and one off and wait. So if you have it turned all the way down, the delays will be 0. So they'll just be flashing back and forth as fast as they can. If you have it turned all the way up, then it'll do one for a second, and then the other for a second, and then one for a second, and then the other for a second. Alright? So if you've got this in, and you've got them all hooked up right, then you should be able to use the dial to just adjust how quickly the lights are flashing back and forth. Alright? And if you still have the buzzer plugged in, I'm going to come over and
at the very top, the one that goes past the ability to see it switching.
Yes.
So it might seem like it's stuck only in one.
Yes, yes. So if you go all the way to, if you're doing this and you go all the way down to like the 0, it'll just look like they're both on. Or only one is on, depending on what kind of delay that it's going on in the code that you don't have to write yourself, because the Arduino people are recording. It handles all the background stuff. Alright? But yeah, one of the things which is interesting to look at when you're doing these is lights that are switching back and forth look like they're turning on and off. As they get faster, they just start appearing dimmer than they were when they were totally on, because it'll be like on and off so fast that it's actually dimming down and isn't as bright as it usually is, as it would be when you're just turning it on. And that's what we were talking about earlier, which is the PWM to do the analog output. And I think we're going to get into that in one of the next couple of lessons. Alright. So I'm going to ask what questions you have about this, and then we're going to move on to 5. Because I like to rip through 5, 6, 7, 8, so that you guys have all the power that's invested in these little bricks. Alright? So give me a shout. If there's anything confusing about analog, or the reason it does that, so the reason that one LED might look a little bit brighter when you go all the way to one end, and they both appear to be on, but one looks brighter, is because if this delay call, if it gets past the 0, it does absolutely nothing. If it gets past the 1, it has to do something else. So if you have it cranked all the way to the bottom, basically this delay line and this delay line disappear. So what you're doing is turning 12 on, so one LED on, the other one off, and then that one off, and the other one on. But then when you come back, it takes some time to actually read from the potentiometer. It takes a little bit of time to read that sensor. So the amount of time that 11 is on is going to be extended by this much time compared to how long 12 is on. So let's say that this analog read takes, 1 millisecond. It means that effectively what you've done is put in a delay of 1 here and a delay of 0 here. Right? So when it's like 15, 16, you're not going to be able to see the difference. But when it's 0 and 1, because it's going to be moving so fast, you're actually going to see that one of them is going to look like it's on twice as bright as the other one. Just the effect that you're seeing there. If you go crank it to one side.
So we're experiencing the latency or the processor
of the internal
itself.
code. Yeah. Because the other thing is, when you're down in that kind of super fast timing, there is other code that runs between the end of your loop and the beginning of your loop that deals with all of the pins turning on and off and reading them and writing them and all that kind of jazz, so that you don't have to do it. And normally you would with embedded microcontrollers. So in addition to this analog reading taking some time, there's other stuff happening between the end of the loop and the beginning of the loop. So it's never good to assume that if you just delay, they'll actually be equal. So there's no questions, or if there are questions, speak now, or we move on to 5 and higher. 5, basically all we're going to do is plug in a photocell. I think they call it a light-dependent resistor. If you talk to anybody who's doing electronics, they're just going to call it a photocell though. And they might not know what you mean. They might have to interpret what you mean if you call it an LDR. But it just looks like a little white thing with a zigzag of metal back and forth. And that also is an analog sensor, and it's going to detect the amount of ambient light. So as you cover it up or shine a little flashlight on it or something, it will detect all kinds of different levels of light. You can use that exactly the same way as you use the potentiometer. So if there's no light, then it'll be at one extreme, and if there's like a flashlight right on top of it, then it'll be at the other extreme. Exactly the same. It's just nice to see that there's other ways of seeing that kind of stuff. It doesn't actually need any new code or anything though, so I'm not going to hang out on that one. And if you don't want or need to see the ability to read light, then you don't really need to do it. Usually when I'm playing with them, I like to use one of the interesting feedback loops you can get going on is if you put the light sensor, plug it in and you're using the light sensor for lesson 5 here, it's turning LEDs on and off. So if you use one of those LEDs to adjust the timing, you have a weird, interesting feedback loop going on where you can actually get various speeds of stuff, which is very interesting. Anyways, if you want to play with that, feel free. You would literally just unplug the rotational brick and plug in the photocell. You don't have to change any of the code, and it'll still just work. If anybody wants me to stay on that, I will, but you have to raise your hand in the next 10 seconds.